So now what we're going to do, we just started our program, and I'm going to check LSOF to see which file descriptors we have open. So all I did was started the program. I didn't enter in any IP address yet. And when I look at the program here, I see OU, 1U, and 2U, and that's standard input, standard output, and standard error. After the program's open, we're ready to enter in the IP address. And then when we enter in the IP address, the first thing that it's going to do to it is it's going to perform the socket syscall. All right, so now at this point, we're going to enter in our IP address. And when we do that, it's actually going to go through socket, bind, and listen, but you'll be able to see right here what happens from socket. So we had 3 file descriptors open. Now we have another one, file descriptor 3. So we created that new file descriptor. Then the next thing that we would do is we would call bind. All right, so our next important step is bind. And initially, when the program first starts up, I have set aside this variable for address that's at this memory location, and I have these values hard-coded in. And then after the user enters in their IP address, the program puts the user IP address right here. So this is the same. This is just repeated. This is the address still. The user's IP address goes here. The port number, which is hard-coded, it doesn't change, is right here, along with a value that represents AFINet. Everything right here gets passed into our file descriptor number 3 that we just created to fill in our socket with a port number and an IP address. And then after that, what we have to do is call our Linux listen syscall, and that changes the state of the socket. So now when I run this and pass in the localhost IP address 127.0.0.1, and then I run netstat to check and see if it's open. So you'll see that it's not open above that, like before running it, and then after running it, when I run netstat, you'll see that 8738 at that IP address is now set to listen. So then our next step will be to call the accept Linux system call. And I kind of started over from the beginning again, but this time I specifically want to enter the localhost IP address 127.0.0.1. And then when I run netstat, you'll see that local IP address is open at port 8738 and it's set to listen. After this, I'm going to telnet into the IP address at that local port number from a different machine now, but you'll see that even though I have this correct port number, it's a different IP address, so it's not accepting the connection. But when I go on the same machine and I type in localhost with that port number, you'll see now it accepted the connection. So now I want to run the same test again, demonstrating accept, but this time just to show that now when I enter all zeros for the IP address, which tells it to listen for any IP address, so now it's only concerned with the port number, which I didn't have the user enter, that's hard-coded into the program. When I run netstat, now I see that port 8738 is set to listen on 0000 IP address. And now if I go to my other machine, it's a Windows machine instead of Linux, and then I try to telnet, it worked. You can tell because it went gray or black, it went all black. And then inside of my program it says connection accepted. When I go to netstat, I see now that there is a connection established at my IP address for my other computer at the correct port number. The code here is pretty long, so I'm just kind of going to go through it as an overview, and I'm going to start by talking about how the code impacts the different parts of the system. So the first thing that you would see as you run this code is how it impacts the console. First, it's going to pop up with a dialog asking for the user to input an IP address. Then when the user inputs the IP address, eventually it'll get to a point where it says it's waiting for a connection, and it'll just kind of sit there and wait. Okay, so that's what the changes you see in the console. Next, you see some changes in netstat. So not for all of netstat, obviously, but just dealing with the specific port number that I'm dealing with. When you first run netstat, you'd see nothing because there's no connection. It's not listening. It's not established. Like, you would just see nothing. Then when it gets to the part of the program where it runs the listen syscall, then you'll see whatever IP address you have entered, colon, the port number, which I have it hard-coded right now is 8738. Then it'll just stay listened until you try to connect, which I've been connecting through telnet, but whatever various ways you would like to try to connect. Once you connect, then it will say established, the same IP address, colon, the same port number, and it'll say established. Then if you either get to the point of the program where it closes the port, or if you were to just exit out of the program, then that IP port number will change to time wait, and then once it times out, it'll go away again. It'll go back to not being there. The next thing that is affected is, I want to say the processes, I think that's the right word. If you run LSOF, and what I actually want to focus on from that is just the file descriptors. So when you first run the program, you'll have 3 file descriptors, and it says test because I named my program test. I haven't named it anything else, so after I compiled it, I named it test. So you got 0, 1, and 2 are the first 3 file descriptors that just automatically open. I don't remember the order 100%, but it's standard in, standard out, and standard error are those 3 file descriptors. Then when you get to the point where you create a socket, you run the socket syscall. It creates file descriptor 3, and then file descriptor 3 is just empty, and then the next step would be to run bind, and when you run bind, that's when it fills in the IP address and port number into that socket descriptor. Listen doesn't affect the socket descriptors, that was affecting the netstat. Then the next thing that happens when you're making a connection is the accept syscall, and when you run accept, it actually opens a 4th file descriptor 4, because that is like the file descriptors for that specific connection. So the next key thing that that I mess with through my program is this place in memory. There's a couple places in memory, but there's one really key one, and that's actually just a struct. In C it would be a struct. If you write this code out in C, you would call it a struct. I'm not really sure if that's the right word for assembly, but I'm going to call it that. So and I have it called address in the program. That's the label that I gave to it, and it just, from running the program, I know it happens to be so far every time I've ran it, it gets created at the hex value 410900. That's the address, the base address, and then you see the 4 words that make up the struct there, and then these are the initial values that I have it load when you first load the program before you enter in an IP address. So everything there is hard-coded, and if you were to write the struct the way humans like to write and think about things, or if you were to write it in C, for example, or actually even in Python, you're going to have the first part would be you want to set the type which would be AFINet, which here that's the numerical 2, so that's the half word 0002 that you see right after to the right of the port number. I didn't label it. And then the next thing you'd have is the port number, and the port number I have hard coded as 2222 in hex, which is 8738. That's also a half word. Then the next thing you need is 3 different words. The last 2 words, they're just padded zeros. I don't remember what they do. They're not relevant to my purposes here. I never had them changed to anything but zeros. But the second word there, so here's our first word, here's a second word, third word, fourth word. The second word is actually the IP address. That's what I have hard coded in. It's hex, but it with the bytes flipped. And then as we run the program, a big chunk of the program, actually the bulk of the program, takes the user input and it converts it to the appropriate format, and then it puts it inside of this address, this part of the struct, right? And so just for test purposes, and most of the time when I was messing with it, I used 127.0.0.0.1, which is what's the right way? I think loopback is the right word. It's the localhost. It's the localhost IP address. And so if you were just to convert that to hex without flipping the bytes, it would be 7F, 5 zeros, and then a 1, because the first byte 127 is 7F, the next byte 0 is 00, next byte 0 is 00, and the next byte 1 is 01. But when you actually store it in memory, the bytes all have to be in the reverse order. So this 01 becomes this 01, and then on the other end, this 7F becomes the last 7F. So that's what's going on there. Then the next part, I want to just talk real quick through the algorithm again from over kind of a big picture level. So what's actually going on in the program. The first thing that we do is we're going to call this write syscall. So the syscalls are calls to Linux, to the operating system. So you just set up the parameters and you make this call to the operating system. And the first one that I have is to request the IP. And so I need to write to the console the statement that I have for request IP. It's something like please enter an IP address or something like that. The next thing that happens is the store the IP, which is done through the read syscall, which just takes that syscall and stores it in memory. I have it store it in memory somewhere. Then the next thing that I do is from the memory where the IP address was just stored, I load each octet into a register. So I have, there's 4 octets. I have each of the 4 octets in a register. So there's 4 registers that are taking up this. But those octets are characters. Read returns characters, not numbers and not hex values, not decimal values. It returns characters. So they have a number 0 is actually in hex. It's 31 or 30, which isn't very helpful if I want to get it into this format right here, right? I need it in just a regular hex format. So then the next thing I have to do is I load each byte into a register. So now this is going to be, whatever, off the top of my head, I think maybe it was like 16. Should be, I think it's going to be more than 16. So you have, there's 4 octets, 4 times 3 is 12, plus 3 decimal places, that's 15, plus 1 new line character. So it should be 16, I believe. So I take each of those 16 bytes now from the 4 registers, and I put each byte into its own register. So now I'm taking up 20 registers just with 4 for the full octet, each octet, and then next I have 16 for each character of the what was entered. And then next I take and I work from right to left. So this is actually easier if you kind of look at an IP address. So I take on the rightmost side, and the first thing I do, because the problem here was this changes length, right? If you have 0.0.0.0, that was 4 numbers and 3 decimal points. This 127.0.0.1 is 1, 2, 3, 4, 5, 6. It'd be 6 characters for the numbers plus 3 characters for the decimal points. So you see the size grows. So in order to handle that, what I have is at the end of it, because I don't know exactly where the end of it is because the length changes, right? So I first look for the new line character. That's my first step. Then from there, kind of everything is actually like kind of happening at once or at different times or whatever. But so first thing I'll do is I'll take my end character and I'll convert it to hex. And this is the 1s digit, it has to be. So I'm going to add it to the 1s for that octet. This is the last octet. And then I check to see if there's like 10s or 100s, which in this case there's not, right? The next digit is the period. So if there's a period, I move to the next octet. So bam, next octet. First thing in the octet has to be the 1s. So again, I'm going to put that to the 1s for this octet. And nothing in this example right here, nothing really interesting happens until 7. So once I got to the 7, I would add the 7 to my variable that I have for the 1s octet. By variable, I actually mean register. I'm putting it in a register. So I would add that to the register. Then next, I move and I see there is something in the 10s place. So I need to take that 2, which would be 32 in hex. I need to chop off 30 so that I have just the value 2. And then I need to take that 2 and multiply it by 10, so that I actually have 20. And then I take the 20 and I add it to the 7 that I had in the register. And then I do basically the same thing for the 1, except I multiply it by 100. So that's this part, and it was a little hard to explain. That was by far the majority of my code is this, and it's really ugly. I'm sure it could be shortened by a lot, but most of my code is actually doing this. Then the next step that happens in my program is we store the IP address inside the struct. So again, it's going to go right here in memory. And then with it being in the correct order, it's not technically in any order from this, but I put it in the correct order. Then I'm going to call the standard things that you would call for a just for a server. So I'm going to call socket bind listen and accept. And then after I allow for user input, actually that's what wait is right there. After the user enters any old random input, it'll go to close the socket and then exit the program.